Hi, so I'm Danielle Rothermel, and I work at Facebook. I work in the Places org, and today I'm going to tell you a little bit more about what my team does. Specifically, I'm going to tell you about how we're building a system to detect user location and to provide that information to other clients within the company to build great products. So first, location information is important. So I think we all can think of many different possible ways of using location to improve a product. So, for example, if we know that you're walking into a restaurant and we know which restaurant you're walking into, then we can surface you information about how your friend checked in here last week and they got the burger and they said that it was great. Or if you're walking into a coffee shop that you visit all the time, then we can say, hey, you've used 9 punches, and so now you get a free coffee. Or whether you're walking into a grocery store and we want to be able to surface the coupons for things that you normally buy. And there's value for products for the stores as well. So as a store owner, it would be great to be able to target ads specifically to people who have actually visited your store, or even better, to target ads to people who have visited stores like you in the area. So there are a lot of different uses for location information. And so how are we going to get it? So that's the problem my team is trying to solve. So let's say you have location and you're going to get this from the phone, you can do a GPS scan, and you've got a latitude and longitude. This isn't exactly what you need. What you really need is information about a place. You need to take location signals and make them into a place entity, whether that's a restaurant or a coffee shop. And so the way that what we're trying to do is provide a black box, which we call a suggestifier, and that's going to take in location signals, and we want to provide you with the place, or provide consumers with the place that you're at and a confidence that this is, so the most likely place that you're at and a confidence that you're actually at this place. And so how are we going to do this technically is the subject of the rest of the talk. So every time I tell somebody with a technical background about this problem in my job, and they're like, oh, this is great. I know exactly how you should solve this problem. It's really easy. All you have to do is take the closest place. You just sort by distance. It's really great. So we know where you are, and we know where all the places are. And so you see what the distance is between you and the places, and you know that you're at the place closest to you. Problem solved, your job is done. So I'm very happy that it's not that easy of a problem. And let's look at some examples where this doesn't quite work. So first example, let's say that you're in a park, and this is kind of going over, like, ignoring the fact that we have to find some way of knowing where these places are. But let's say we have place pins for all these places. While you're in this park, you're walking around, it's a huge place, and when we sort by distance, then the place you're closest to is actually this place outside the park. And so we're surfacing you information for the McDonald's when you're enjoying this peaceful park. And that's not a great user experience. But at the same time, that's kind of an edge case. You can probably take care of it by itself and, like, I don't know, deal with big places. So let's look at another example. Let's say you're actually on the street near a place, not a big place. We've got place pins. But even though we do have place pins for these different places, they're probably not all located in the same part of the place. So they're probably, if we're doing a really good job, then they're somewhere in the footprint of the building, right? And so then on top of that, if you're in New York, then a building doesn't just contain one restaurant. It contains maybe like 10 different places. And so now you've got a lot of place pins. And then when you add to this that we get your GPS location, and so we have a latitude and a longitude, but it's not exact. We also have an accuracy associated with this location. So really, we've kind of got a radius around you that says you're somewhere in this circle, and that makes our job pretty difficult. So sorting by distance, not really ideal. And we can look at a specific example. So let's look at Manhattan. One thing we haven't really talked about is how would we even plot an example of this on this map? How do we associate user, like a check-in, how do we associate GPS location with a specific place? Like, where do we get that mapping from? And so one of the easiest ways that we found to get that mapping is when a user checks in or tags a location. So the user has said, I am doing this, I am triggering some action that surfaces our location that we can log, and then also this action means that I am actually at this place now. And so when you put those together, then we can map the check-ins of users in this general area where the different spots are different colors are different places. And you see a mess. So, and this is just some of the places, like this is a sample. And so you can see things like there's a green spot in the middle that's like kind of well defined, but then you've got a lot of other colors that are all scattered. And it's just, in any of these places, it's pretty unclear which place you should associate that lat long with. And you can zoom in and it still doesn't, it gets a little bit more clear, but it's still not really that great. Location signal alone isn't enough. So that's what makes the problem fun. So our team takes a variety of location signals, including latitude and longitude, of course, and accuracy, but also things like Wi-Fi fingerprints, Bluetooth fingerprints, social context, and uses those to produce this place and confidence estimation. So now let's look at how we actually do that. So we have separated I think many people, and we have separated the steps of this into 3 logical steps that also align with our modules of our code. So first, we have a candidate fetch, and that is going to take us from our huge places database that has millions, billions of places in it, and narrow it down to a small set that we can actually score, because we can't, it's very expensive to score all of the places. We want to score a small set. And so the goal is that this set actually contains the place that you're at. So it's small enough that we can score it, but it also has the place that we want to surface. And so we have candidates. Then we do feature extraction. So we describe these places based on different qualities that will allow us to be able to separate between the places that you're not at and the places that you are at. And so that produces candidates plus feature vectors, and then we do confidence estimation, which is running it through our machine learning system to get candidates and their confidences. And so then you can surface just the one with highest confidence or multiple depending on what your product wants. So let's break this down into the pieces. First, candidate fetcher. So input signals, like I said, location, Wi-Fi, the country you're in, app type, things like that, come in and you get a list of candidates. And so I do a lot of debugging on this, and I see these 3 places all the time: Facebook New York headquarters, and then the Kmart downstairs and the Starbucks next door. So this is a realistic candidate list. And so how do we want to do this candidate fetching? One way that seems kind of apparent is there are probably other use cases where there's been some type of ranking, some type of places ranking. Why don't we just use that as the candidate fetch? So we, of course, do have that. We have check-in ranking. So when you are trying to check in somewhere, there's a place picker that ranks where you probably are trying to check into. So originally what we did was we just took the top 3 places from that. But that was really expensive. And so initially our clients really only needed a low number of queries per second, and this worked. But we quickly got to the point where even though this is much better, we couldn't sustain it. So we moved to other options. So one great way is, as we said, distance from user. So distance from user is great for doing a candidate fetch because the place that you're at is probably one that is close to the location that GPS returned. So take the 3 places you're closest to, or in places you're closest to. Another thing is drawing a radius around you and then saying popular places. So out of the places within 50 meters, which ones have the most check-ins? And so we're going to say of the top 10 most popular, we'll rank those. And this works pretty well. You can also do a combination of a few different things that are lightweight. And what makes this really useful and very efficient is the geospatial indexing service that supports it. And so we use a combination of these, and we can have very high QPS. It's fairly inexpensive. So that's how we do candidate fetching. And now we have our candidates, and we move on to extracting features from them. So for each candidate, we want a vector of features that describe it. So there are a few different the highest importance categories of features that we use. The top one is spatial representation. So the goal here is to represent what's the probability that you're actually at place X, given that we know that you're at this specific latitude and longitude. So if you look at these birds and these dots, the blue dots are all check-ins to a single place. And so in the first case, it's pretty clear that you are in the center of all the blue dots to the same place. And so the spatial feature should say that it's a pretty high probability that you're at that place. And it should push the model in that direction, so it should be a high score for this feature. And then in this next case, though, you see that there is a cluster, but you're not really close to it. But you are close to a single check-in. And this is actually very important. It highlights the importance of outlier detection. So with check-ins, most people check in the restaurant. But then some people check in when they're at home. And we don't want their check-ins while they're at home to like completely influence how these features perform. So outlier detection is actually a pretty big deal. And then this last example is probably the most interesting. So in this case, you have a lower probability. This last example is pretty interesting, multiple clusters. And so it's not really clear what to do with this, because this could be coming from a variety of different situations. So if you're in an airport terminal, then there are probably 3 or 4 other airport terminals that all correspond to the same airport. And we would like to identify that you're in that airport. And so you've got clusters, and you want them all to represent the same thing. But at the same time, there are clusters where if you're a store and you moved from one location to another, you don't actually want to consider the old check-ins, you only want to consider the new cluster. And so it's a combination of being able to use multiple clusters and also maybe having some type of time-based component to the spatial feature. But it also highlights the fact that you're probably not going to be able to distinguish some of these situations without other features, which is why this is not the extent of the model, it's just a feature in it. Another important feature set are things like Wi-Fi features. So the idea here is that you look at what Wi-Fis people were connected to when they checked into each place. And so if you're Mr. Cactus and you're connected to Wi-Fi A, we think you're probably at the orange place because everybody else who was connected to Wi-Fi A was also at the orange place. And so clearly it's more complicated than that, but this is the general principle. And Wi-Fi works really well for things like buildings that have many floors, and also for things like buildings where you have 2 restaurants right next to each other that have check-in clouds that bleed over on top of each other. It does a good job of separating out situations that are hard to identify spatially. So then one more feature category is background features. So we're scoring each of these places individually. And so we do have information about the places, like how many check-ins have happened at this place, things like that. But at the same time, the surroundings actually matter. So if you're a certain distance from a place, and then you're much, much farther from all other places, we should be more confident that you're actually at the orange place. But you can be the same distance and be pretty close to other places, and then we should be less confident in this situation. And so being able to capture information about the surrounding area in the features is important. So when you combine these features with others, then we do feature extraction and we move on to confidence estimation, the last step. So we take our feature vectors, and out come our candidates and their confidences. So Facebook uses gradient boosted, my team on Facebook uses gradient boosted binary decision trees. And so I guess we do our training offline and we do our scoring online, and so we don't really care about how long it takes to train the model, but we do care about how fast it scores, and generally these perform well. But we also, my team does not do the actual implementation of the model, but we have found it very useful. So we train it. And the big thing that is our question is, what can we use to train this model? So we can extract features, but how do we do the labeling of these features? And so this whole time I've been talking about check-ins as a source of ground truth. So a person says that they're at a place, and so we're going to use that. That makes sense. But there are a lot of biases in this. So a person only checks in when they actually have intent. So we only get that information when they pull their phone out and when they actually like go into the Facebook app and use it, right? But we want to know about places if a user has given us permission to use their location history in the background, then if they go into a bar and they don't pull their phone out, we still want to be able to identify that they were in that bar so that later we can know that they like bars more than restaurants or something like that. And so that's a completely different use case. There are types of places that you don't get to see in check-ins, like grocery stores people don't check into that much, and laundromats, things like that, that like, you'd be surprised sometimes what places people check into, but you get much fewer. And so this is kind of an open question for us of like, where can we get this linking between the signal and a belief that a person was actually at a certain place? So this is kind of a big area. And that describes the justifier. So at the beginning I said some of the hypothetical products you could do with location information. Some of those were hypothetical, and some of them we actually have tried. One thing you might have seen are place tips. And so this is popped up at the top of your newsfeed, and it said, see photos and post by your friends at Aputo. And so you could see more. They're photo tagging. So if you've taken a photo somewhere, it'd be great to be able to say, hey, was this Santa Cruz? You should tell all your friends. Internal APIs, of course, and then ads products, very useful. And so the key takeaway is ranking by distance isn't enough, but location information is really useful. Thank you.
Thank you, Danielle. So we'll open up for questions. We've got 5 minutes for Q&A. Yeah, go ahead.
So with regard to GPS publics, altitude report, do you guys have you taken that into consideration?
Yeah.
Repeat the question if you could.
So the question is, in New York where altitude is important, have we taken that into consideration? And that's something that we've thought a lot about. So presumably GPS provides altitude information as well, but my understanding is that it's not always accurate enough to be able to use for this type of situation. And so we've been thinking about different ways to do it. Some things I've heard floated are things like, I don't know, barometer information and stuff like that. But I think that we haven't settled on something that like has solved this problem, but it's definitely important. And Wi-Fi, I think, is kind of, at this point, our like main attempt at doing that, because ideally that will break up different buildings.
Okay. Another question, but one other one about Wi-Fi features. Like, how do you get that information? Like, I have a router in my coffee shop. How do you know where I am from someone's device?
So I know there've been a lot of different iterations of the Wi-Fi features that we've been using, and it's still something that we're actively working on. But one thing I know we've tried is that like we can see the Wi-Fi name, for example, and you can do name matching things that are like remarkably effective, like some more effective than I would have thought. So I know that that's something that has worked for us to an extent. Sure.
So Wi-Fi, is it not just Wi-Fi you're connected to, but also Wi-Fi's that are available in the area?
So yeah, ambient Wi-Fi and connected Wi-Fi are both useful and available to varying degrees. So yes.
So I know you can get Wi-Fi SSIDs, like you can scan on Android and you can see the whole fingerprint and then do a reverse lookup for when somebody checks in. You can go and store that and then look up and say, okay, that looks very similar. But you can't do that on iOS. Do you guys have 2 parallel systems, one for iOS users and one for Android? Or do you have one system that can account for the bias in both of those technologies and merge that?
Yeah, so that's a good point. And it's something we've been dealing with recently. But repeat the question. So the question is, do we have 2 different systems for iOS and Android, because you have different signals that are available in each. Specifically, Wi-Fi is available in much more useful ways on Android. And so we have one system, and it at this point, what we do is we train models that use the Wi-Fi features, and then if they're available, then it just performs better, and if they're not, then it doesn't. So, yeah.
What role, if any, does the vendor play in the system?
What role does the vendor play in this system? So they're deciding how to interpret the question. So I think one role that the vendor could play in the system is that if the products that use our information have like stores, for example, that maybe care about the products working well, and so they might provide us, for example, ground truth data for their stores or something like that. And so that's one way that we have contact with the vendor, but our team doesn't specifically interact with vendors. Yes?
You mentioned using social context at the beginning as like a helpful indicator. Can you
Yes.
talk about like, it sounds really cool how it's used and how it helps?
Yeah, so the question is social context and how it's used and how it helps. So we do use social context. At this point, it's an open question of how heavily we should use it, and that ideally, in a perfect world, if we had two people who were standing in the same spot, then we would identify them in the same place. But since we're not in the perfect world, it does help to know that some people like bars more than coffee shops. And so we have tried and to a varying extent do use things like category features and also like the user's past check-ins and things like that are like the main way. Yeah.
All right, last question. Rock, paper, scissors.
My last question from Jurassic Park.
Okay.
You have this technology that you can find out where people are, but should you do it?
Should we do it?
Why want you to know where I am?
So the question is, if you have this technology, should you use it? Should you know where everybody is? I think there is a combination answer here. One is that it's not everybody, right? So these are people who specifically have said that their location services are on, and at least on iOS, I know there's something that like pops up a few days later that says, are you sure you want them to have your location services? You know, so it's like, it's a set of users that have like specifically said yes, for the most part, at least on iOS, which I know more about, I guess. So there's that, and then there's also, I mean, I can't speak for everybody. For me personally, I think it was a little overwhelming to realize when I joined the team how much information that Facebook has, you know? But it also was something, it was also very impressive and shocking to see how much effort went into things like privacy control and how little access I personally had to the data, which was very reassuring. And it was, I think you can make really cool products with it. And I think as a consumer, I really, like, the idea that my phone, like some app, any app, could make it so that when I went into my favorite coffee shop, I don't have to carry the little piece of paper that says, like, you've used 3 out of these 5, you know. There are a lot of products that I would find very useful with this data. So, yeah.
All right, Danielle, thank you very much.
Thank you.